And I'll tell you the reason why this is one of the most interesting topics because there are a lot of interesting updates going on with Claude bot coming on. My name is Aditya. We've been discussing a lot of topics related to RAG, large language models. For the past 10 plus years, I've just been working in terms of human body positioning, personalization, AI, computer vision, and have been publishing papers. The buzz and the noise which has come out there. And this is especially because of OpenClaw. I'm assuming a lot of you guys must have heard about the term OpenClaw. I'm going to give a quick brief, and my name is Aditya. We've been discussing a lot of topics before related to RAG, large language models, and today it's one of the most interesting topic. And I'll tell you the reason why this is one of the most interesting topic because there are a lot of interesting updates going on with Claude bot coming out. There's an IT stock pricing which crashed because of that, and there are a lot of things going on. So before that, I'll just give a quick brief. So for the past 10 plus years, I've just been working in terms of human body positioning, personalization, AI, computer vision, and have been publishing papers in the same domain. I've been building and creating production ready systems. I'm founder of Create Bytes, Yug AI, Alteryx Labs, and I've been doing a lot of activities around it. But the interesting fact is the buzz and the noise which has come out there. And this is especially because of OpenClaw. I'm assuming a lot of you guys must have heard about the term OpenClaw. So you might have seen a trending press news. It's the open source autonomous AI agent that in just a couple of months went from a niche GitHub project to one of the most talked about tools in AI. And OpenClaw began like, let's say, a Claude bot. And then there are a lot of things which started happening. So you have OpenClaw in a manner where you can set up a VPS and then install it and start doing a lot of activities via accessing the machine. And it's like your personal AI assistant working very closely with you. And you guys should visit the website, look at the videos, and see how it works. Some online reports you won't even believe, like one of them is covering a story where emergent behaviors, like so-called, which is like a kind of religion created by machine generated posts. But those are largely social experiments and the interpretations of what happens when autonomous text agents interact at scale. And I'm talking about Moldbook, which you guys should visit and check. It's like a Reddit style social network where only AI agent post and interact. You can definitely call an API and do it yourself and it looks like human, but a lot of them are basically just agents closely interacting with each other. Now, what's actually documented though isn't that AI agents have mystical beliefs or these kind of things which are coming up. They basically having some kind of security concerns when doing those activities. And one example which happened just few days back is there was a database which got misconfigured and it briefly exposed millions of API tokens, email addresses, and private messages. This is something which is again a concern, and this is a reality. So building autonomous agents that can do things, access files, execute code, send messages, introduce engineering complexity, security risk, and trust. And that basically create a question for us, academia, like how we should be deploying it, we should know about it, and how we can ensure that a safe, secure, reliable, and production grade system is built. And that's what we are going to be learning today. And the most important engineering layer, if let's say we call it the foundation of modern agent systems, it's basically LangChain. And today we are going to do a deep dive in that. And before we initiate, I'm going to basically quickly stop here and say what exactly is this LangChain. So strictly speaking, a lot of juniors think it's just a Python wrapper around, let's say, OpenAI. When they call it, they can use it, but it is not. LangChain is like an infrastructure. Think of it as the operating system or middleware for applications. Because in production, the large language models are not only the single component, like the CPU in a computer, but your application also need memory like RAM, tools, input IO, workflows, retrieval from a disk, and logging mechanism which your kernel does. So LangChain give you an architecture and not just an API call to OpenAI. So in India, we built with constraints, with limited, let's say, GPU budgets, very high latency sensitivity on mobile networks, and mixed cloud setups. So what we need is efficiency, and that's what something which helps any industry, any business to get much more faster return in ROI on spending amount on GPU. So LangChain helps you build something that survives real traffic and real users, and not just a demonstration that works on a local host. And it is important to understand. Now, if we quickly jump to the next thing, you'll see a couple of more detailed scenarios and interesting facts about LangChain. It's like an open source framework. It is built to help developers move beyond prompts, and it goes in the direction of, can we go do much more things than just using the LLM with the normal prompts? So the raw LLMs with, let's say, GPT 4.5, Claude 4.6, or even 5.2 GPT, open source Llama, are amazing at generating text. But by default, a large language model is stateless. It forgets everything the moment the API call ends. It can't click buttons or query your SQL database safely. It doesn't know your internal PDFs or, let's say, your customer history by default when you just have a pure call. And the same input can produce different outcomes every time you use it. So in 2026, building AI is not about calling a large language model. It's about building a system around the large language model, which is like a brain, which can do model reasoning, your hands, the tools and functions and the APIs which you can use, and then accessibility around it, memory, which is like a state management with context present there, and a process, which is like workflows and guardrails which are present there. So imagine you want a WhatsApp sales agent for an Indian e-commerce brand. It must read your product catalog, check availability in your warehouse, calculate pricing in rupees, create a PDF code, and log in the Salesforce, or let's say a CRM which you're using. It is not a prompt. It's not like that you can do all these things with just a single prompt. This is like a workflow with tools, memory, observability, and all these things coming along. So LangChain is like a glue that connect these blocks one by one. Now the question comes in, why LangChain exists? What is the problem which it is trying to solve? Why do we need a framework? Because if you try to build a production application using raw LLM APIs, you end up with what I call immature LLM code. And that is the biggest problem. What you will see, prompts are scattered across 50 different files in utils and other places. You have put the prompts, ad hoc string concatenations are everywhere. No memory strategy, context is lost between messages, no safe way to call the different tools. And the biggest issue is the hallucination. I definitely would love you guys to look at the YouTube video in the webinar where I've explained technically what exactly it is. But what happens when you ask a probabilistic model for facts without any kind of grounding present, it creates a lot of wrong pricing strategies, fake legal citation, broken JSON that crashes your backend. A lot of things happen. So LangChain exists because we need standard abstractions. It makes things more modular so that you can swap the models easily. It is easy to trace and track where exactly the issue can arise. And then the most important is production ready. It handles retries, timeouts, fallbacks, and all these things. In our ecosystem, production ready means handling flaky networks, API rate limits, suddenly spiking to 10 times tracking after let's say a reel goes viral. So you need a framework that handles that robustness, that maturity is needed, and that's where the LangChain comes in the picture. Now, the interesting thing, what are the main key features? So in 2026, prompt engineering is not like asking something nicely or whispering to the AI and then sending a message and then trying to get a response from that. It is a proper SDLC cycle with a lot of software engineering aspects which come in the picture. So let's say we defined a prompt earlier in our past webinar where we defined that you need to have a role, you need to have a force schema, that is output must be valid JSON or SQL. You need to specify the tools, which tools are allowed and not. You need to define the failure, what happens if you don't know. So hallucination is reduced significantly, output becomes consistent, and your downstream code stops breaking when you do that. So for example, one basic thing which one should always ask, and you'll get an answer in our next slides. Do you store prompts in the Git? Do you have version control scenario when you're using those? Do you have A/B testing when you're using those prompts? If not, you're not actually doing these activities in a production ready manner, but you're just basically playing around with it. So it's important that we follow these things in the right direction. And now this is the diagram which can explain to you about a modern AI stack. It's somewhat similar to how you write infra, where you have prompt, retrieval, model, and parser. So abstraction, which works in this manner, is one of the first and most important is LCEL, which is LangChain Expression Language. It's a pipeline language. You compose components which are prompt, retriever, model, parser. So like, let's say Linux or Unix pipes, one output become the next input. And this is important, like you move from one to second to third. You can swap the models, like you can change from OpenAI to Claude, or vector DBs can be present without rewriting your entire application. And that's why LangChain Expression Language becomes LCEL becomes important. And then you have integrations. So real applications connect to almost everything. You can, for example, the current Claude bot can connect to Postgres, Redis. You can have your PyCon vector DB present. You have Amazon Web Service API calls for platform as a service scenario, WhatsApp APIs. So LangChain give a consistent interface layer for all of these. Now you have chains, agents, and retrieval mechanism. Chains are deterministic workflows. You move from A to B to C. Retrieval, like it's again RAG systems for grounding the knowledge, and it's important. And finally, agents, dynamic decision makers when the path is not fixed. Now, let's talk about LangGraph, and this is huge. If you want an agentic system or even Claude Cop, what happens is you need to have loops. Like agent can go back and check and then come back again because it is trying to get to the final result. And then you need planning, like you talk about orchestration agent that direction, and then correcting errors. So for all these scenarios, you use LangGraph. It allows for stateful multi-actor workflows. So this is important. And then you have LangServe. You deploy your chain as a REST API. This is what production teams need: an endpoint, an auth, scaling mechanism, and versioning. And then we talk about LangSmith, observability. So debugging, evaluation. When your agent fails in front of a user, you need to trace a log, what prompt went in, what tool did call, and then where did it hallucinate. Without this, the application will look like a black box, and that's why LangSmith plays an important role. For example, let's say you're building an end-to-end sales orchestration. You need to ensure that you know where exactly it failed so that it doesn't fail again. It helps you in terms of debugging. So again, the LangGraph, LangServe, LangSmith are the three terms which we'll get into detail later on too, but are very, very critical and important. Now, this is important. What is the life cycle? So the end-to-end life cycle, if you look at, you have ingestion where you bring the data from PDFs, Notion, databases. Then you apply retrieval with RAG, like you do chunking, embedding, and store. Let's say, so the answers are grounded on the basis of this particular ingested data. Then you have agents, which are the main decision makers. Your dynamic logic is sitting here. You choose the tools, you decide the next steps, and then you move on. And then finally, you have LangServe, which is basically the deployment mechanism. You turn it into an API and your front end can call the backend in that direction. And then the LangSmith, which track failures, run tests, and monitor quality. Now, important thing, LangChain turn large language model, let's say these kind of scenarios where we've been using it for experimenting API calls into some kind of real-time production-ready use cases. And it is not like model has become smarter. Your large language models are still the same. The problems which we discussed in our past webinar, they are still the same. But because we have made sure that we have created a disciplined engineering around it with the help of LangChain. And this is important to understand. And again, the role of RAG in a LangChain system is very interesting and important. We have touched in detail about the RAG system, but at a very high level, if there's one thing you need to understand is important fact that you cannot depend on just the answers which directly come from API call, or let's say the way you use large language models, because these are probabilistic engines and they are not exactly the truth engine. Let's say if you ask GPT 5.2 about a specific RBI policy which has changed that happened, let's say yesterday, or about your private internal leave policy, there's a very high chance that it may hallucinate. It will give you a very confident, well-written, and absolutely wrong answer. Why? Because that data wasn't in the training data set, or that data was not present in the data set with which it was being built upon. So it's confusing and it sometimes basically just create issues. And that's why RAG solves this by flipping the model from memorization to like an open book exam kind of a system, where you have retrieve, which works in a direction where you can take relevant external information from your real data sources. Then you inject that specific text into prompt window. Then you ground that generation in that evidence. LangChain make this pipeline practical and scalable, turning a, let's say, a normal creative writing tool with factual grounding coming in that direction. So it's important that we understand the importance here. And how does LangChain enable RAG in its pipeline? Again, it's important. LangChain standardizes this flow into a strict pipeline. You can't just hack this together with, let's say, you write some Python script and you want it to scale in that direction. There are multiple steps which are taken care via the framework. Number one, you have document loaders. So what we do is we ingest the raw data. Then you have text splitters. We chunk that data into digestible pieces. And chunking is something which is an important activity. And there are a lot of very good library. I strongly recommend you guys to look at Embed Anything. I've been experimenting with it and it's very powerful. The name is Embed Anything. It can do embedding in such a fast manner. It uses Rust behind the scenes and it's very powerful. So you have text splitters and then you have embeddings. So we convert those chunks into mathematical vectors. Now, vector stores come in the picture where we store those vectors in a database designed for similarity. Then we have retrievers. We fetch the exact chunks needed for a query and then finally change. So we combine that retrieved text with the prompt to generate the answer. This ensures that the model answer using evidence and not guesses. If the evidence isn't there, the model says, I don't know, which is an enterprise setting in a feature and not a bug. And this is important that we should enable when we create a system, we ensure that factual groundedness is present in all the scenarios. And that's why, like when you're using LangChain, you get this by default. And so you can build on top of it. Now, it's important to consider the bigger picture, which are like, what are the different components and how they work? So when we build a RAG application, we build them from small reusable pieces. So at a very high level, we follow the principle of separation of concerns. So it's important to understand this principle and why this creates an important direction. So you have retrievers which handle knowledge. Their only job is to find the right document. Then you have agents which handle the decisions. Their job is to decide what to do with that document. Then you have prompts which handle the instructions. Then you have tools which handle the action. Why do we separate them? Important to understand, because in production, your retrieval logic might need to change. Let's say switching from pine cone to some other direction without breaking your agent's reasoning logic. So this separation makes the system easier to understand, debug, and following the same solid principle which we have learned so far in our college as well as when we were studying computer science. In that solid, you have open for extension and close for modification. Always remember. And that's why separation of concern becomes important. You don't want a monolith. You want a, let's say, a kind of a micro components present in the system. And now we basically talk about an interesting thing, which is the entry point in this entire framework, which is called as document loaders. So start with document loaders. In let's say a real world scenario, data is messy. You have PDFs with weird formatting, REST APIs returning nested JSON, SQL dumps, Notion pages, all these things are present. LangChain loaders normalize all of these things into single standard object called as document. A document object is simple. It contains page content, which is like a text, and the metadata. Never ignore metadata. When you ingest a PDF, capture the file name, the page number, and the upload date. Why? Because when you retrieve data later, you need to filter. You need to be able to say search for leave policy, but only in document from 2026. Metadata filters are going to help you in terms of like creating much more scalable system. So while you are having page content present as part of the document also has a concept of metadata which one should not be skipping or ignoring. Now we are going to jump towards the text splitters. What are these? So, for example, 90% of RAP pipeline fail because we do not have these set up in the right direction, and that's why chunking is critical. It's not an option. LLMs have a problem of context window. They have a limit to which they can grab the context. And not just LLMs, like you can talk about BERT models, named entity recognition models. There is a context problem. Let's say you can have 500-page document, just say, okay, create the embedding for this entire thing. No. So we must chunk the data, but we don't just chop it up blindly at every 1,000 character. If we want to do it in a proper direction, you cut a sentence in half, you lose the semantic meaning. And this is important. So we use a concept which is called as overlap. Overlapping ensures that if a sentence is cut in the middle of a chunk, the second half appears in the next chunk with some context from the previous one. If we have better chunking, we'll have better retrieval and we will definitely have better answers. So if your chunks are too small, the model lacks the overall context. And if they are too big, you confuse the retrieval search. So it's important that we understand that why chunking is critical. There are a lot of good chunking models out there. If you look at it, one of the things which I use for chunking and embedding, I've told you about it, which is embed anything, which is quite powerful. And then you have embedding models, which are basically, we have talked about it in past too. This is the math, which is writing it in numbers. So this is like we convert the text into vectors, list of floating point numbers. Why do we need this? Because computers do not understand meaning, but they understand distance and geometry. And in vector space, Similar meaning things are gonna be nearby from a vector perspective, and different meaning things will basically be a little far apart. For example, Delhi is mathematically closer to India, king is closer to queen. This allows semantic search, finding things by meaning, not just by keyword matching. If a user search for human resource rules, a semantic search can return documents containing employee guidelines, even if the word human resource has not come in there. And this happens only because of embeddings in a crux. And then we have indexes, which are very important from the scalability direction. So we store these vectors in a vector store. Let's say we can save in Deep Lake or Pinecone. This optimize lookup create a scenario where we have a very fast way to search something. So it increases the speed for us. If you have 10 million documents, you can't compare your query to every single one in a linear manner. That would take forever. Indexes map text to embeddings. There's a very famous algorithm which is called as HNSW. So they use these algorithms to find the nearest neighbors instantly. It allows us to search millions of documents in milliseconds. Indexing is something which make a RAG scalable for enterprise usage. And without it, what you're doing is basically just trying to search something which cannot even come out, because we are talking about millions of documents. So this is important in terms of scalability direction. We have even learned indexing in past when it is being used in production grade databases too. So it's important to know the reason and importance of it. The most interesting topic. What are agents? We are moving from chains to agents now. So far, what we have talked about is A to B, B to C, but agents are different. So the single most important shift in AI engineering in 2025, 2026, where they become so powerful, so powerful. Just this week, there's a IT stock getting in a very difficult position. Why? Up until now, we have seen chains which are like linear workflows where they go from step A to step B, which leads to step C, and they're rigid and they're safe because we know this is how it need to be. But most of the activities which we do are very non-linear. So agents are systems that use large language model as reasoning engine to determine the flow of the application. So instead of flowing in a very hard-coded manner, and that is one important thing which we need to know whenever anyone asks, what is the difference between an agentic system and a workflow? This is the difference, that agents use large language model as reasoning engine to determine the flow to reach the final target for which what they are intended to do. Workflow is very much focused towards the direction in which it has to go, and it's a kind of, it can be dynamic, but a lot of like if you look at it at a very holistic picture, it's hard coded to be built in a certain way. So what to do next based on what is the input of the user? There are basically choices which it makes with respect to tools. It can use dynamically, let's say reason step by step to solve a problem. So it can say that, okay, this is not working, let's move on to this one. This is not working, I want to use Gmail to send an email. So this turns the large language model from a passive text generator or a conversational AI system into an active problem solver. Think of this as a chain in a track. So what happens, like very interesting. So when you have a train, you have a track and it has to follow. It can either go forward or it can go back. And most of the time it is going in one direction. But when you have a car, there's a traffic, you can take a U-turn, you can move here and there. That's basically a very simple example of understanding how a regular chain system works versus how agents are intended or we make them work. And that's important, that they observe, they figure out things to achieve their final target. And this is important. Now, the important concept is how agents work and the loop in which they create the scenario. So think, act, observe, and decide. This is important. So how does this actually work behind the scene? It's important to know that the main framework in which they are working. So they first think, then they act, then they observe, and then finally they decide. So what is the stock price of Tata Motors right now? For example, if we ask something like that. So the agent receives instructions. So you are a financial assistant. That is the prompt reasoning which we have given. So the large language model analyzes the request. It realizes that it doesn't know the current price because its training data is old. So it decides to act using a tool which basically is, let's say, fetching the data from the stock price database. So it says, fetch the stock price data to fetch that. So that's the place where it is acting. And then it observes. That tool executes the return statement of, let's say, $2,000, $1,000, $500, whatever the stock price is. And the agent reads this observation. And then it processes this new information and generates the final answer for the user. The cycle happens in milliseconds. But it's important to know that we have not implemented memory or loop limits. And this is exactly how agents like OpenClaw may, or in future you'll see this happening, that they can get stuck in infinite loops and they may be burning your APIs. Important, very important to understand, when we are building agentic systems and when we are building the frameworks, they will be working on their own, but you need to put a limit, the kind of memory they want to use and the kind of APIs or the number of loops they're gonna get into. So you have to put loop limits, and it is important. So it's very much strategic. We'll get into the detail, but the main crux of the matter is the agentic loop system works in a manner where you think, act, observe, and then you decide what's happening. Now, this is the strategic layer, which are like the different agent types. So LangChain isn't something like one size fits all framework, and we need to understand this thing. It supports multiple cognitive architectures, and you can call them as agent types. Why do we need different types? Because different tasks require different brains. Each agent type defines these three things in detail. Decision making, how does it plan? Tool selection, how does it pick up the right API? Reasoning structure, is it fast and intuitive, or let's say it's slow and deliberate? We can combine these or customize them in a step-by-step direction. In a very production-ready stack, you might use a fast router agent to get the tickets and a slower reasoning agent to solve complex technical support issues. So it's important that these three things, decision making, tool selection, reasoning structure, they define what kind of agent type or the strategic layer you are building in or you want to use. Now, one agentic type which is important to understand is called as zero shot react agent. And I am 100% sure that whosoever has worked in this agentic framework or building agentic framework, they must have heard about this. If not, this is something which will help you get much more broader in-depth understanding. Zero shot react agent. It's basically the prototyping king. It's like this is what it is built for. So the classic architecture is the word. Just think about the word react. It stands for reason plus act. It interleaves thought, I should check the database, with action, querying SQL. So basically that's why it's reasoning and act. Zero shot means we don't need to provide specific training examples. We just give it the tool definition. It relies entirely on the tool description string. If you name your tool search data but describe it poorly, the agent will fail to use it. And that's how it happens. So it's important that we get into a little more broader understanding of the word react and the zero shot meaning. And then you just provide that tool description there. So it's a very interesting way for fast prototyping because it's easy to set up. But for high stake production environments, I won't use it. It can be slightly unpredictable in a lot of direction. So it might try to use a tool in a way which we don't intend it to do. But yeah, for fast prototyping, for building things up at a faster pace, zero shot react agent is something which you guys can use. The other one is structured input react agent. So one was zero shot react agent. This is structured input react agent. And this is a production standard. For production in 2026, we lean heavily on structured inputs. And this is important. And that's why the structured input react agent become like one of, let's say, one of the many good agents which are being, agent types which are being used. So let's take a problem. So real world APIs are, let's say, predefined. So your internal API expects user ID with 123 user ID, region name, let's say Delhi. And the agent basically sends ID 123 and city Delhi. Your code is going to crash because agent has sent ID, but your expectation was user ID. It has sent region as the other JSON key, but agent has sent as region, but we were expecting electricity or other way around. So your code crashes because it was not sending the right key and the value which is needed. Structured input agents don't just generate text, they generate schema compliant arguments. So, and again, that's why another library, Pydantic. Okay, so that's why we use Pydantic models to define the exact structure the agent must output. And I have been using Pydantic. You guys should also explore this. This is quite good. And I've used it for a lot of applications in production so far. And this is something which you can consider as one of the standard things which happen with specifically structured input React agent. This drastically reduces invocation errors. If you are building an agent that interact with your company's payment gateway or ERP solution or some external APIs, let's say you're using Twitter APIs, Insta API, you must use this pattern to ensure reliability and safety of the system. And this is important. And we are now going to jump towards the next one, which is OpenAI function agents. These are very specialized brain systems. And I'll tell you one fact, like this is something which has been used for a lot of powerful applications built so far. So if your stack is built on OpenAI, let's say GPT-4, GPT-5, you should use OpenAI function agents. You don't need to go at other places. You have something which is quite powerful. Why? Because OpenAI fine-tuned these specific models to detect when a function should be called. It is much more robust than asking a generic model to please format this JSON. So this allows for a safe tool invocation. The model adheres strictly to the function signature. It has a predictable output. It stops the model from chatting when it should be coding, and it's important. In the overall, let's say, current example, we often say that balance cost versus performance. Let's say I want to know how much of my outcome is versus the cost which is coming in. So these are very much cost effective, especially in case of OpenAI, because they've been built with and for OpenAI. So definitely worth looking into. And then self-ask with search agents. And this is very interesting. These are multi-hop reasoning kind of agents. Sometimes the user asks a question that cannot be answered in one step. Who was the Prime Minister of India when the first iPhone launched? So a standard search may fail here. The self-ask with search agent breaks the complex query into simpler sub-questions. Question number one, when did the first iPhone launch? Who was Prime Minister of India in, let's say, 2007 when it got launched? And then we have Manmohan Singh was the prime minister. This technique is called multi-hop reasoning. It significantly improves factual accuracy because it grounds every intermediate step in some kind of retrieved data concept. And that's why self-ask with search agent is a type which is also quite popular and has been used at a lot of places. Now, again, jumping towards another agent type, which is called as plan and execute agents. These are like long horizon tasks, like long-term execution scenario, and planning and execution is needed. And that's why the name plan and execute agents. For very heavy tasks like research this competitor and write a 5-page report, we use plan and execute agent. This separates the project manager from the worker. Let's say phase one, we have to do planning. The agent plans all the steps upfront. First, I will scrape the website, then I will analyze pricing, then I will summarize features, then we went towards the phase two. It executes these steps sequentially. Why do this? Because with a standard loop, the agent often gets distracted halfway through a long task. So it's important that there is basically a loop which goes towards the plan, checks it, and then come back and execute that. So this architecture keeps it focused. What's the trade-off? It has a very high latency because it does a lot of thinking before it starts doing the items. But yeah, for very long horizon tasks, plan and execute agents are quite powerful to use. And now we are going to quickly jump towards some powerful available and custom tools which we can use to build applications with these agents. I'm going to quickly recap and just touch the agent types again so that you remember after closing this session what we did. So one interesting thing was we learned what are these agents, how these agents work, but the different types of agents are important. Just learn it. One was zero shot React agent. And the important one was REAA capital. So that means zero shot React agent. These are reasoning plus act. And with zero shot, you just give it and then it's going to come back. We learned about structured input React agents, where we ensure that we try to have an API response in a very structured manner. There, if you remember, we use some libraries like Embedding Models, ensure that you have structured in the right direction. So structured input React agent, zero shot React agent. Then we talked about OpenAI functions agents. If we are working with OpenAI, these are the best ones to use because OpenAI has done a lot of fine tuning on top of it to ensure that we can work with them. So OpenAI function agents are the third one. Then we have self-ask with search agents. Again, multi-hop reasoning. Remember that question. Who was the Prime Minister of India when the first iPhone launched? This kind of question and the kind of problems which can come in, self-ask with search agent can help in answering them. Okay. And then for a very long horizon task and activity where you have, let's say, multiple workers, project managers, plan and execute agents are important. So zero shot React agent, structured React agent, then you have OpenAI function agent, and then you have self-ask with search agent. which are multi-hop agent, and then plan and execute agent, the fifth one, which is long horizon task. Now, quickly. So agents are only as smart as the tools you give them. I can actually give OpenClaw my calendar access, my WhatsApp access, my Telegram access, whatever I'm using. I just give OpenClaw my access, and then it can work at night with me to do a lot of activities. I was trying to build a very powerful system for the last 15 days, but with OpenClaw, a lot of things were taken care automatically because OpenClaw is a framework to access these tools. And so the line which I say, agents are only as smart as the tools you give them to use. And it is important. So LangChain come with powerful built-in tools in that. Let's say Python REPL. It lets the agent write and run code to solve mathematical problems. Search tools, Google, Bing, and others. Database tools, SQL executors. But the real value for you lies in the custom tools which you can build and create. And I'll tell you one thing, at Create Bytes, where I've been building a lot of products and scale them, we have wrapped our internal APIs, our CRMs, our timesheet, our products with these custom tools. And these are very much domain specific actions, like check the balance, check the corresponding mechanism of how people are being viewed. These are like what we have done. We have taken up our own products and then we have built our own custom tools to use that. That is what we have been doing for other purposes whenever we're building agentic frameworks. Now, this is important to understand. Building large language model powered applications, there's an important concept which is called as orchestration. When you bring all of this together, prompts, retrieval, agents, tools, and memory, you get a full LLM powered application. This is the difference between, let's say, when we are trying to build a small tool versus when we are trying to build a production ready system. We have to handle the retrieval integration to fetch the private data, agent reasoning to handle the logic, and then memory handling so that the bot remembers the user's name from 5 minutes ago. The architecture allows us to build real applications and not just some basic demos which are present. Now, I'm gonna jump towards some kind of prompt templates which are related to the roles and context. I've touched this topic in our last webinar, but this is important to understand. Let's jump into some kind of code components to here. So chat prompt templates are how we manage context. We don't just send a string, we structure the message into roles. So you have system message. This is God mode instruction. For example, you are a helpful legal assistant, speak in formal English. There's a human message. This is the user's input. This is separation. Try to understand this difference. When you have user's input versus you have system message, there's a difference which can come in. This separation helps the model understand its intent and maintain consistency. In production, these templates are often dynamic. We inject user data, let's say date, time, and other things, and retrieve context into system message before the user even speaks. So what you're doing, you're basically, again, try to understand. We inject the user data, the date, time, their message, and retrieve the context into the system message before the user actually speaks and does something. So we need to distinguish how we define the system message versus how the human messages are coming out. And this is important. Now, we talk about a concept which is summarization chain. And this is related to document processing. One of the most common enterprise use case in a very general scenario is document processing. Enter the summarization chain. Enter the concept of how one should be processing the document, which is a real pain point for years. And like there are a lot of methods and solutions which have come out there. But from our context, let's try to understand. His job is to ingest large documents like annual reports or legal notices, condense the information, and produce a controlled output. So if we look at, let's say, the code, what we are doing in this code, we are initializing the large language model. Then we use load summarize chain. Then we use PyPDF loader to ingest a PDF file. And then we run the chain. Under the hood, this handles the complexity of MapReduce, splitting the doc, summarizing chunks, and then summarizing the summaries. It's essential for processing long PDFs and articles. And try to understand this code. And definitely this something like this you guys must have already seen when you are coding or doing activities with respect to documents. Again, in the beginning, we have initialized the large language model. Then we use load summarize chain, where we basically call the function. Then we use PyPDF loader to ingest a PDF file. Then we run the chain. And behind the scenes, it handles the complexity of splitting the doc, summarizing the chunks, and then summarizing the summaries themselves. Now, another application which one should know is chat, which is called as the QA chain, question and answering chain. And you would have seen a lot of RAG systems have RAG agents, and this is something which is the Q&A agent which is being built with those. This is the heart of the entire place where whenever anyone wants to have any kind of RAG system being built, they would definitely want a chat system to be present with it. So it answers questions using a prompt, but critically it need a retrieval context. So without retrieval, QA chains will, and I won't even say will hallucinate. So we use deterministic settings like temperature. We if you remember, we discussed about temperature in the previous webinar to ensure, let's say we put temperature equal to 0, and there can be other numbers too which we can put in, and this basically creates a kind of an answer where it can be very accurate, it can talk about at a very high level, this is the outcome, and there are a lot of other parameters which one can set in to ensure the model doesn't get creative with respect to facts, and it basically spits out exactly what is needed. You can, let's say, put temperature equal to 0. The code pattern LLM chain combine the model and the prompt into a reusable function. This is the fundamental building block of all the grounded chatbots. QA chain is definitely an interesting example of using it. Now, again, this is important. LlamaIndex. Let's talk about it. So I'm sure you must have heard about the name LlamaIndex. You may not know exactly what it is. So I'll try to create an association. If LangChain is like the general manager of a company, then LlamaIndex is the chief data officer. Its entire focus is on ingesting, structuring, and retrieving private domain specific data with very high precision. Okay, my association would have helped you relate to it. Like LangChain is like a general manager, LlamaIndex like is the chief data officer. That means what are we doing with the data in the entire system? Ingesting, structuring, retrieval of the data, and the most important part is how accurately we are able to do these activities. So while LangChain is great in terms of orchestrating everything, LlamaIndex is good when we have very messy, complex data, let's say GBs or terabytes of unorganized PDFs, Excel sheets. It, in a very overall direction, turns our data into an API that large language models can actually query. And this is important. Now, another important factor, and we've discussed this in our past webinars too, which are, let's say, embeddings and vector stores. So LlamaIndex relies on very important aspect, which are embeddings. It has to, in order for it to be very good, very accurate, it need to have this understanding. And semantic search is the topic which comes in the second we talk about embeddings. It compares vectors and not keywords. LlamaIndex high level philosophy, if you just try to understand at a very high level, if the right information is not retrieved, the LLM cannot generate reliable answers. So it doesn't matter if you use GPT-5 or tomorrow a new large language model version come in. If you feed it garbage context, you get a garbage answer. Very simple. LlamaIndex optimize the retrieval step to ensure the context is perfect. And to do that, it's important that we convert the data into pure embeddings. And then we have Pinecone and others where you can save the vectors and then use it, and then you can index it, and a lot of things can happen with it. Now, this is important, which is like called as deep lake vector store. And this is the place where we touch the topic of multi-modal part. So very important component in this whole ecosystem is deep lake. This is a vector database built specifically for AI workloads. It's like there are a lot of them available. It's not just one of them. To give you an example, when you have a standard database, you're trying to input a text or let's say images and other things, and then you store it. But with deep lake, it supports multimodal data. It can embed for text, audio, image, and video in a side-by-side direction. And it's important to look at the structure. In the next few webinars, we'll get in more detailed scenario of how multimodal data can be saved. But just think of it, deep lake meaning you can actually store multimodal data in a very efficient direction. So it offers dataset versioning, like let's say what we do with Git, our source code repository. Deep lake provide dataset versioning, and think of the importance of something like that happening, how powerful it can be. And it integrates seamlessly with both LangChain and LlamaIndex. For any kind of advanced RAG application involving image search, video search, deep lake is one of the best choices to go about. And then we are going to touch the data connectors, which are Llama Hub. So real world data lives in silos like Google Drive, Slack, Notion, SQL, Outlook. Different things are present at different places. Writing scripts to scrape those data sets from different sources, it's something which we've been doing for a long duration of time. LlamaIndex solve this with a concept called as data connectors, which are nothing but data readers. Through Llama Hub, you have the access of hundreds of read-only mode loaders across these places. So you can import a Notion page reader or a Slack reader with a single line code. It automates the fetching and conversion of raw data into standardized initialize document objects. It's important what happens with it. But just remember, data connectors, it's Llama Hub. And now I'm going to talk about nodes. And consider this from a perspective of smart chunking. So in LlamaIndex, we don't just have chunks. We also have a concept of nodes. A node is a chunk of text, but it carries rich metadata along with that. Which document it came from? What was the previous node before this one? What is the next node which is going to come out? This relationship significantly improves the retrieval accuracy when we have rich metadata stored in a node. So the code snippet shows us how we can have simple node parsers to turn documents into these smart nodes. And this is a huge upgrade over simple string splitting concept. So instead of splitting the data using string with 10 character, 100 character, we use a concept of smart chunking. And that smart chunking comes with the concept of nodes. And I'm going to jump to the next one, which is indices and vector store index, which is, you can consider this like an organization concept. So once we have nodes, we organize them in an index. The most common one is the vector store index. It takes your node, calculate their embedding, and store them in your vector database. Now you can think about the efficiency with which we are moving towards and the kind of things which are coming up. So from LlamaIndex to Llama Hub to going towards nodes and then finally like indexing those nodes. These are interesting. So when you query it, it performs a similarity search to find the top K most relevant nodes. And you would have heard about the top K when you use RAG. So this is simple, scalable, and effective for 90% of RAG use cases. And whatever is like a general production ready RAG, they use these things on a very regular basis. So that's how you do the top K most relevant nodes in this fashion. And we're going to jump towards query engines. So how do we get an answer out? We use query engine as the bridge between retrieval and generation. So it has two things which it takes care of. Retrieves the relevant nodes from the index and then synthesizes the final answer using the large language model. As you see in the code, index.as query engine. So index.as underscore query underscore engine. It creates this engine instantly. It abstracts away all the complexity of prompt engineering through the context. So it's important to understand how query. So again, two things: retrieves it and then synthesizes it. It synthesizes the final answer using the large language. Just remember that when you are doing query. And a code snippet can give you an idea that index.as underscore query underscore engine. And that creates the engine immediate effective. And then we're going to jump towards another important aspect in this ecosystem, which are called as routers. These are advanced traffic controllers. So as our system grows, a single index isn't enough. We must have one for legal, one for human resource, one for other. So as we grow, there are different indexes. So this is where routers come in the picture. A router analyzes the incoming user query. What is, let's say, the severance policy and decides I should search for human resource index, not the legal index. It routes the query to the correct data source. This reduces the noise and ensures better accuracy when working with multiple knowledge bases. And that's why when you are scaling up, you have routers coming in the picture. And then finally, we are going to touch a topic which is called as saving and loading. And this is in a very defined manner called as persistence. And this is like a very practical thing. Creating embedding costs money and time because we have to use GPUs. You do not want to re-embed your 1,000-page manual every time you restart your Python script. LlamaIndex allows us to save it to the disk and reloads it later. And this speeds up development, our overall production grade scenario, and also reduces the cost at a very fast pace. So for any production system, index persistence is important, and not just important, it's basically mandatory to do it. So saving and loading with persistence is important. It's like a practical thing which happens almost every time. And I want to touch the data framework again and the topics which we touched. We talked about LlamaIndex, which is important. Then the LlamaIndex, the way data is being stored are vector stores and embeddings. And in vector stores and embeddings, we touched Deep Lake Vector Store, which basically takes care of your images, audios, videos, everything in that direction. Then we had Llama Hub, which were data connectors. Like you must be having Notion, then you have Slack, OneDrive, drive, G drive. So Llama Hub or the data connectors take care of that. Then when you are doing chunking, it's not just the string chunk, but what you do is you try to get the rich metadata, like which document came from, what was the previous node, what's the next node. That is basically nodes, and that is the concept around smart chunking. Then we also touched about when these nodes are created, then we have indices and vector store index for these nodes also, which are related to the organization. Then we jump towards the concept of query engines, which are basically like at a very high level, you can consider that you have the retrievers and then you have synthesizers together working. That was basically query engine. And then you touch the routers, which ensure that when you scale, you can route towards different node indices or nodes with, and then your query engine works in that fashion. And then we touch, to save the cost, we have persistence, where you basically save the data to the disk and reload that later on whenever you need it. So that's how you basically define it. Now, I'm gonna quickly do a very high level comparison so that we can see the overall system of how data is being handled. LangChain versus LlamaIndex versus OpenAI assistance. When it comes to data handling, LangChain is great for standard formats. Okay, it's modular and adds new data points easily on it. And you guys can see how it happens. LlamaIndex, this is like a champion of data. It links the chunks, uses deep metadata, which we just talked about, nodes and smart chunking, and handles complex vector stores natively. So that's LlamaIndex. And then you have OpenAI Assistant. It handles files up to, let's say, 512 MB. It can go beyond that, but it's like a black box. You don't control the chunking strategy on your own. And that is important to understand in terms of the comparison. Now, I'm going to do another comparison, which is the LLM interactions with these three. So earlier, we compared when it comes to data handling, what's the difference between these three. Now we are comparing when it comes to LLM interaction. So LangChain has the maximum flexibility for any kind of large language model interaction. You can define custom chains, swap models, and use extensive prompt templates in doing it. Now, LlamaIndex, they use large language models primarily to manipulate the data, which is indexing or querying at the time of retrieval. And like where exactly we'll be using the place where we had the query engine, where we had the retrieval and then synthesizer present there. So it's very much focused in terms of its use there. OpenAI, we are logged into some kind of GPT ecosystem. It's powerful, but we are completely dependent upon their API and their pricing. And now I'm going to quickly do a comparison with respect to querying. So when it comes to LlamaIndex, it offers advanced techniques like sub questions and hybrid DE, which we call as HYD. The LangChain excels at agents and observability. And we talked about observability. If you remember, the name was LangSmith. They are good at that. And they are complementary. And like if you look at this from querying perspective, and not just from querying perspective, from LLM interaction perspective, and also from data handling perspective, like they are not exactly like conflicting that if I use this, I cannot use this. They are actually complementary. So in a very 2026 stack, if I talk about, I use LlamaIndex to handle my data layer, but I'll also use LangChain to handle the application logic. So it's important to understand that you use them together and not compare them in a direction where they conflict with each other. Each and everything has their own use case and power to use. So that's why like use it in the combination and build very powerful agentic stack in that direction. And so we have covered a lot today. We have covered LlamaIndex. I was thinking about giving a very detailed workshop on how you can use OpenClaw to do a lot of activities. Let me know. You can follow the Insta channel, and then the second you're gonna scan the barcode, you'll observe that there's a link of Insta. Once you have followed, you'll get a message where you can join the open source community. We've been publishing a lot of GitHub repositories too. Some new repositories around LangGraph, LangChain, and repositories around, what do we call it? The agentic systems can come out with some examples of building simpler agents, much more complex agents, LlamaIndex and all these things. But there'll be some things which are related to OpenClaw, which we'll also be publishing. So guys, just follow it, join the community on Discord, on WhatsApp, and follow on Instagram, and you'll be able to see a lot of interesting things happening from this scenario. And at CBX, our focus is majorly the outcome to build a very powerful career defining portfolio for real AI products and projects, because that's what we do at CreateBytes, and that's what we have been doing and trying to build kind of AI knowledge, AI reference, inference, which can help all of you guys to grow at a very fast pace. And again, thank you very much for joining in today.